Okay, student, today I will refresh again for your lesson 5. There's a light, because some of the students they asked about this topic for the form 4, maybe they forget already. So I recall back chapter 5. There's a light. Okay, let's see the first one. There's a 5.1. There's a refraction of the light. So this one is a syllabus for the form 5 student. Okay, let's see here. Okay, first one, the topic we're talking about reflection of the light. So everybody did know what's a refraction. So this one photo, they show about the refraction from the sea. Okay, we go to another one. Okay, from this one lesson, later we need to show about the diagram of the plane mirror, incident ray, normal line, and refracted ray. Okay, incident angle and refracted angle. So this one I will draw and show you. Okay, number 2, we must know about the law of refraction. Okay, number 3, you need to draw about the ray diagram of the mirror. Then we need to state about the characteristic of the image formed by the plane mirror. Okay, number 4, we state about the characteristic of the image. They formed by the refraction of the light from the plane mirror. Number 5, what means of laterally inverted. And the 6, we need to compare about the real image and also virtual image. Okay, this one, there's a sum of the diagram to show what is a refraction of the light. Okay, mirror, they work as a refraction of the light. Let's see the diagram. So using the mirror, you find the light that will refract back. So this one is one of the example for the refraction of the light. Okay, now we need to go about all the angle, all the label for the refraction of the light. Okay, this one is one of the diagram refracted from the plane mirror. The plane mirror should be the smooth surface. Okay, OA. The OA, they stand for incident ray. OB is stand for the refracted ray. Okay, then center one. The center one must be 90 degree with the plane mirror. This one we call normal. Okay, there's a ON. Okay, the next one we got angle. The angle is between the N and also the A. This one we call it as an incident angle. Okay, you can say about angle of incident. Then the N between the B, that one is a refracted angle. So from here they got explain what means of normal. Normal, there's a line at the right angle to the mirror surface. Okay, number 2, what is an incident ray? Incident ray is a ray from the light that's directed to the mirror surface. Refracted is from the mirror surface. So for the refracted ray, there's a ray that's refracted by the mirror surface. So this one is a different with the incident and refracted. You can see about the angle. Okay, the next one, what is the I? What is the R? So I is an incident angle. So the keyword is the angle between the incident ray and also normal. Refracted ray also between the normal, but this one is a refracted ray. Okay, remember must between the normal. The other side, this one, between the plane mirror, this one is not related. This one not incident or refracted angle. Okay, so the next one is a law of refraction. Law of refraction, we got 2. First law is a angle incident and also angle refraction must be the same. So I can say I and R equal. Okay, what is the second law? The second law is a incident ray, normal, refracted ray, all will lie at the same plane. What's the plane now? The plane now is a mirror. So that means the 3 lines must meet at the same plane. So this one is the second law of the law of refraction. Okay, so we finish about the first part. We know about the structure for refracted. We know about law of refraction. Okay, then we continue the next one. Okay, the next one should be the characteristic and also the image they formed by the normal plane mirror. Okay, this one is some of the example of the diagram. Okay, we see it, what is the characteristic. Okay, when you see, that means when you stand in front of the mirror, first one you can find it, the size of the image must be the same. Image and object, the size must be the same. So this one for the plane mirror means a normal mirror. Okay, the distance also same. That means you move forward or you move backward, how many cm, how many meter, then one your image also follow. Okay, so image distance, object distance must be the equal. Okay, the next one, virtual image. Virtual image means you cannot uh, cannot form on the screen. Okay, the mirror, not the screen. If I put the screen on the mirror, that means you cannot see your image. That one we call virtual image. Virtual image, the definition means the image they cannot capture on the screen. That one we call virtual image. Okay, later we'll go through about virtual image. Then laterally inverted means left and right are interchanged. So that means the object, you leave your right hand. Then the image in the mirror, they show about the left hand. So this one we call laterally inverted, just left and right only. Okay, last one is the upright. Upright means you standing, the image also standing. If you inverted, that means the image also inverted. So this one means the image from the mirror, they will follow your position. So this one we call upright. Okay, then we go and see the next one. Okay, rear image. Rear image means the image that can be seen or you projected on the screen. That means when I project the image on the screen, then you can see the image to come out. Okay, let's see example here. Okay, first one is a projector. Projector, when I just show on the screen, that means you can see it. Okay, if I take something to close the screen, I put one book. Okay, I put another white paper to close the screen, but you still can see the image. So that one we call rear image. So from here example, that one is outside of the window, the mirror. Then you see the tree. After go to concave mirror to come back on the screen, they will capture on the screen. So this one we also call rear image. Okay, this one is an object, the bulb you on already. Then a refractor from the mirror. Then this one the screen, they capture. So you get it. This one is an image that form on the screen. So this one we call it rear image. That means you can see on the screen, not on the mirror, on the screen. Okay, now we're going to see the virtual image. Okay, virtual image, just one of the word changes, there's a cannot. Virtual image is an image that cannot be seen on the screen, or they say cannot be projected on the screen. Okay, example, normal mirror in your house. Okay, if the mirror you see your face, okay, if I'm using the screen, example, the white color screen, the projector screen, you go to close the mirror. That means you totally cannot see anything. You cannot see your face already. So that one we call virtual image. So anything they just capture on the screen, sorry, not on the mirror. So example, the first one, you can see the house inverted. Then you see your hand become bigger. You can see the candle. This all is a virtual image because they just capture on the mirror. Okay, if I'm using something to close the mirror, that means there's nothing to show. So that one we call virtual image. Okay, so from here we know there's a virtual image that's formed by the mirror. Okay, and then we need to know how to draw. Okay, the image must exactly same the location as the object. So the distance must be the equal. So from here you can see A, B, C until F. The distance to the mirror and the image you from the mirror must be the equal. So from here we need to know the concept, the ray how to travel. The ray must travel from the object, then hit the mirror, then the mirror will refract it to your eyes. Then your eyes can see the image. So the ray travel must start from the object. Okay, so the arrow you must follow the concept. From the object, hit the mirror, then the mirror refracted to your eyes, then your eyes see the image. So normally the image is behind the mirror. Okay, the image is behind the mirror, so we're using dotted line. Dotted line means there's a virtual line. We cannot see one. Okay, so from here we need to know how to draw. Okay, first one, the example they call you to draw. Draw must start from the object. So you make sure your image must be behind the screen, and also make sure the distance is the same. So the question normally they give you the image already, then they provide object, then they call you to draw. So the first one we just start from the A. Okay, from the A we draw one straight line, arrow go hit to the mirror, Then you can start for two of the line, focus. Okay, when the two line they hit to the mirror, okay, then these two line must go to your eyes, refracted to your eyes. Then they refracted to your eyes, then you straight forward go to the image. So the last line must be, okay. So from here, make sure you know these two parts. Okay, you can see here. Okay, this one is what I want to show. You hit to the mirror. Then after that, the blue light will go back. Then go back. Then after that, you focus to the image. Okay, so this one is a reflection. From the mirror, make sure you know how to draw the line from the object. Arrow hit to the mirror. Then they're refracted to your eyes. Then your eye focus to the image behind the mirror. So make sure AB and BC, the distance should be the same. Okay, this one is one of the example diagram. Okay, this one is a diagram of the object. Okay, when I just refracted from the mirror, so this one is an image they formed by the mirror. You can see the situation. There's a virtual image because you cannot capture on the screen. Number two, you can see upright. That means the cartoon at the top is it. The final, the image on the mirror, the cartoon also at the top. The word at the bottom. Okay, then the sign should be the same. Okay, just you find it laterally inverted. Okay, they start with the S here, is it? They start with the Y. So this one we call laterally inverted. Okay, plane mirror is finished. Then we need to see about the curved mirror. We got two types of the curved mirror. So this one we call concave mirror. Okay, concave mirror, can you see all the rays? They are parallel to hit the concave mirror. Then after that, they will refracted back. When they're refracted back, they just go to one point. So this one point, we call it focal point. So finally, you can find the image, they become focus. Focus means they will go to the one point. Then you can find the image become sharp and also big. So this one, we can produce the bigger image from the concave mirror. Okay, how about the convex mirror? Convex mirror, you can find the shape. There's a go outside. The mirror, they will go outside. Then after that, you find it all the parallel light. When it just hit the mirror, they also will focus. But they focus to behind focal point. Behind focal point means virtual already. Okay, after that, they will divert. They will open wider, go outside. So that means later we see the image, they are not focused. They go further already, means later you can see the image is a bigger area. Bigger area means the image becomes smaller. Okay, they can show more area, but you can see the image, you focus, they cannot clear. Okay, so this one is what's different for the concave mirror and also convex mirror. Okay, we see some example of the light ray. This one is a refractor of the light from the experiment. You can see the light ray. Okay, the four light ray, they go straight. After that, this one is a barrel. They hit to the concave mirror. After that, they will refract back. They focus to one point. So we call it as a converging to the focus point. So this one is a convex mirror, and the light ray also barrel. Okay, after that, they will divert. Can you see the light? They open wider. So this one we call diverging. So that's why finally you can see the image is bigger area, but this one image is a small area. Okay, so we go to the next one. Okay, now we go to the curved mirror. Okay, we got so many structure here. They got label C, F, and also P. Okay, so from here we need to give the meaning for the every structure here. Okay, we go through the concave mirror. The first one you see what's a P. P is a center of the concave mirror. So we can call this a pole of mirror. That's the center point of the curved mirror. Okay, C. C is a just like the center of the circle. Okay, center of the circle. So we call the center of the curvature. Geometry of the center of the hollow sphere, of which the concave or convex mirror is a part. So that means C is a one circle. There's a tick at the center point. Okay, what's the principal axis? PFC. PFC just one of the center line. You join the C, you join the F, and also the P. So there's a line that passes through the center of the curvature. There's a C, and also the pole of the curved mirror. So this one we call principal axis. Okay, then we following go and see what's the F. F we call principal focus. You can say about focal point. Okay, F-O-C-A-L, focal, focal point. There's a one of the point that through the which all ray traveling parallel. That means all the ray that just parallel, they must go to find F. Okay, to the principal axis, convert to the appear or you say divert from the after refraction by the mirror. So any ray, when it just goes straight, they will convert to the F, or they say divert from the F. So this one we call focal point. Okay, then we go to R. R is a radius of the curvature. So R actually is the same like the distance C to P. We call radius. So distance between the pole P and also the center of curvature, we call it as a radius. Okay, now important is this part, focal length. Focal length is a distance, okay, we label by small f. There's a distance between the principal focus, there's a capital F, and also the pole. So from the P go to the F, we can label this one as a focal length. So I draw here. Okay, from the F, you go to the P. So this one we label as a small f. That's a focal length. Okay, from the P to F. Okay, then we go to the ray diagram. So we need to draw. So I will introduce the three ray, how the light ray when they hit to the mirror, how they're refracted. So later we need to join the line, join the ray. Because one of the ray we cannot draw the focus point. Okay, because one of the ray you cannot overlap. So at least it's two ray. Two ray, then we overlap, then we get the point. Okay. So from here I introduce three of the point first, three of the ray first. Okay, let's see the first one from the concave mirror. Okay, concave mirror, remember there's a focus. Okay, when we draw, we never draw hit to the concave mirror. We hit to the straight line. So normally we assume the whole straight line is a concave mirror. So the first ray, okay, remember the first ray. Okay, the first ray must be parallel. This one is an object. Okay, from the object you straight parallel, you hit to the concave mirror. So when you hit the mirror, sure they're refracted, is it? So they're refracted to the F. So this one we call first ray. Okay, how about the convex mirror? Convex mirror, there's a divert, they cannot focus one. So divert later, they will open wider. Okay, let's see how to draw. Okay, we also parallel first. Then after that, they will draw focus to the behind F, the virtual focal point using dotted line. Then after that, you make the line become longer. So this one we call first ray for the convex mirror. So this one is diverging. So this one is focusing. Okay, we go to the second ray. Okay, this one is one of the example. If I'm using the ray diagram, okay, you can see the straight line, okay, the parallel. After that, hit the concave mirror, they will refract it to the focal point. So this one is a focal point. So they say a ray parallel to the principal axis refracted through the F. So this one is an example. Okay, now we go to second ray. Okay, second ray, they just reverse with the first ray. First ray is parallel first, is it? Second ray, there's a go to the F first. So let's see the first one. They go to the F. Okay, after that they hit the mirror, they must refract it, is it? Now they're refracted parallel. Okay, the process we just reverse with the first ray. Okay, for the convex mirror also same. The first one, they go to the F first. Okay, in front of the mirror we're using full line, behind the mirror using dotted line. So they go to find the F. After that, they will parallel. Parallel from where must be here refracted. Cannot say the F refracted. We cannot see the F. must be refracted from the mirror, so they're refracted out. So this one we call second ray. Okay, let's see the experiment one. Okay, I just show about the concave mirror only. So when they just go to the F first, okay, this has a focal point. They straightforward go to the F, hit the mirror, then they are go up parallel. So this one is a second ray. So the ray passing through the F is refracted parallel to the principal axis. When they just come out the light ray, there's a parallel with the principal axis. So this one is an example for second ray. Okay, now we go to the last one. Last one is a third ray. Third ray is a simple one. They're just one line only because they go and back should be the same line. Okay, there's a go to the C. So you see the first one, they go through the center of curvature, hit the mirror. Then they also go back at the same position. So you can see they're just one straight line, but they got two arrows. Okay, for the convex mirror also same, but this one the C is a behind one, there's a virtual. So from here we draw like this. Okay, the straightforward hit to the behind C. So normally here we're using dotted line lah. You help me to change. Okay, when they refracted back from the mirror, also is the same line. So third ray just got one line only, and you must remember they go to the C only. Okay, let's see example. Okay, this one is a ray from the ray box. From the C hit to the concave mirror, then you can find it, they're just one of the line. They don't have any refraction line. So from here we can say the ray that passing through the C is refracted back along the same path. So this one is a third ray. So now we learn about first, second, and third ray. Now we need to combine. Okay, when we combine, we need to find where's the image. Okay, let's see the following. Okay, before we want to draw, I want to introduce the image location. Okay, first one, I draw one of the T shape, then separate by 4 parts. Okay, first and third. First and third I label L. L means lenses. They're just using for the lenses. That means later if we're using the lenses, the image we produce as a part 1 and also part 3. But today we're using is a mirror, so they're not related. So from here later we see the image, sure at the location 2 and also location 4. So that's why I label here is a 2M, here is a 4M. So part 2 and part 4, M stand for mirror. Okay, so now we're going to see another one. Okay, this one above the horizontal line. Then this one is below the horizontal line. So that means later we see the image either at the part 2 or either at the part 4. So if we find the image is above the horizontal line, we call it as a virtual image. Okay, if they just appear below the horizontal line, we call it as a real image. So this one is depends. Later you draw and you see where's the location of your image. Then finally, you write the characteristic. Okay, we go through. Okay, the first one. Okay, I label for you first. This is a concave mirror. So I label for you. Either 2, either 4. Here is a virtual, here is a real. So we're just using first and third ray. Okay, let's see the first situation. U less than F. What means of the U? U is a object distance. Okay, where's the object distance? I label first. Okay, this one called object distance. Okay, from the O, go to the, this one is a mirror. So this one we call object distance. This one is labeled as a U. Okay, this one we label as a F, focal length. Agree, yeah? So this one we also can label from the C, straight forward go to the P. This one we call it as a 2 focal length. Okay, so this one is a label first. U is a object distance. This one is a focal length. This one is a 2 focal length. Okay, first situation they say u smaller than f. So is it u smaller than f? This one is a half of the f only. So that means we find the object distance less than the focal length. So this one is the first situation. Later the object we will move, go behind and behind. Okay, means they go to the f, more than the f, more to the c. So later we see what's happen for the image. Okay, from here we start to draw. Okay, first one, remember we're using first and third ray. Okay, let's see the first ray. Okay, this one is a 2m, part 2. This one is a, this one is a part 4. So this one is a 4m. Okay, so from here we're going to see the first ray first. Okay, first ray is parallel. Okay, then they will go to find f. Okay, then the next one, they will, using the third ray go to C only, is it? Then we go to the C. Okay, now can you see they cannot cross? The bottom one sure cannot cross. Okay, so from here we need to extend until to this part. This part they got chance to cross. Okay, to cross over because they closer already. So from here we extend. Okay, this one is a mirror. Behind the mirror using dotted line. Okay, this one dotted line. Blue color also using dotted line. So finally I find it cross already. Okay, when they start to cross, that means I got 1 point. Okay, the point is here. Last one, how to draw the image. When you start to draw the image, must always start from the horizontal line. This one is a horizontal line. You must start from here, go up. Okay, so you cannot say, oh, from the point I go down. No, you must start from the horizontal line and you draw. Okay, so from here the object, the shape is an arrow shape. So your image also must be arrow shape. So remember this part is a virtual part. So virtual using dotted line. So you see the image. So this one is a image. Exactly same like the object pattern, but this one dotted line. Then we compare the size. Is it the size become bigger or smaller? So the answer should be bigger. So final image become bigger, is it? So now we go to see what is the characteristic. First one, there is above horizontal line. The image is above horizontal line, then sure is a virtual. Okay, number 2. Now I want you to compare the object and image. Is it upright or inverted? That's upright because the head is a top. This one head also is a top. Okay, number 3. The size become bigger or smaller? The size become bigger already. So from here I can write the characteristic. Virtual, upright, magnify. Magnify means become bigger. Okay, so this one is how we go to write characteristic. Okay, then the following, I want to go to I want to move the object. Okay, just now is the object less than f. Now I want to move the object, go behind some more. Okay, let's see here. Okay, so you help me to change, and this one not 2m, this one is a 4m. Okay, so from here I move the object until to the f. Okay, we're still using 1 and 3. Okay, this one also remind you 2 and 4. Okay, now we start with the first ray. Okay, continue, go to the f. Okay, second ray we want to use using third ray. Straightforward, go to C. Okay, from the object, go to the C, make it longer until hit to the mirror. Okay, can you see both sides also cannot touch? Although they cannot touch, we still want to make it longer. Okay, extend the line, become parallel. Okay, after extend, I still cannot touch. So this one situation means your image is very far. Your image is a very far distance. So that's why we cannot capture on the screen. So from here, we know this one that is an image. The image must be location at the part 2. So part 2 means sure is a virtual image because you are above. Okay, second one, I say there's a very far. Very far means there's a very big object. So just like the star, just like the sun, there's a very big object, so that one is a magnified. So one more, above one sure is a upright. Okay, because you focus, you go upper. After that, we need to draw from the horizontal, is it? So we start from the horizontal, we draw, so sure is a upright. And the last one, you need to add one more, magnify, because there's a large image. And one more, you need to add infinity, because they cannot capture on the screen and very far. So from here, we see characteristic, the extra one more, virtual, upright, magnify, and also infinity. Okay, we just add infinity here because when you draw the parallel line, they cannot join together. So we say the image at the infinity. Okay, so this one is the first situation when the object in front the F and also exactly the F. We get the image is a virtual and also upright. And one more, that's a magnified. Okay, now I want to continue to move. Continue to move the object, go further. Okay, now it's a F, is it? Now I want to go further. That means maybe I go here. Okay, between the F and C. Now you see this one situation. I move the object between F and C. So this one I can say now the object distance is between F and 2F. Okay, for this one situation, we're still using 1 and 3. First ray and third ray. So this part again, there's a 4 mirror. Part 4 for the mirror, not part 2. So I start again. First ray. Okay. First ray parallel, then go to 5F. Okay, then I continue with the third ray, is it? So the third ray must start from the C. Okay, so this one must be hit to the mirror lah, because the space is not enough. So they must hit to the mirror after that and come back. So you find it there's a 2 arrow. So finally they cross. Okay, they cross already. So this one cross means you get the image. Okay, now how to draw the image? I told you before the image must start from the horizontal line to draw, is it? So you see the horizontal line is here. So how to draw? Must start from here, go down. Okay, draw the arrow, go down. So you see the image. So this one image go downwards. Okay, then this part is a 4 mirror, part 4. So there's a below the horizontal. Below horizontal line, there's a rear image. When there's a rear image, we no need to draw dotted line, we draw the full line. Okay, now we conclude the characteristic. Okay, first one, this one is a rear image because there's a below the horizontal line. Okay, number 2, can you see the size? Okay, bigger or smaller? The size become bigger. So we can say magnify. Okay, one more. Can you see the first one, the object is upright. There's a go upper. The arrow is point up. How about the image? The image, the arrow is point downwards. So this one we can say the characteristic is inverted. Okay, inverted and not laterally. Laterally is the left right. This one is inverted means upside down. Okay, upside down it changes. So from here the answer is rear, inverted, magnify. Okay, so you can find it when the object they just move after the F, after the focal point, you already get rear image. Okay, you cannot get virtual already. Virtual is inside, when the object inside the F. So from here we also can conclude virtual image always together with the upright. That one is a partner. Okay, when you just take the object out from the F, you sure will get rear and also inverted. So rear and inverted is a partner. Virtual and upright is a partner. So the size you must depend. Then you need to compare. Then you know what is the size. Okay, then we continue to move the object. Okay, now the object is between F and C, is it? Now I want to move the object, go to the C. That means now the object at the 2F. Okay, we see what happened. Okay, now again, this one is a 4 mirror. Okay, now I move the object already at the C. So we say U equal to F. Okay, U equal to F, that means we cannot using third ray already. Okay, we cannot draw the third ray example exactly the same line, is it? The focus, the C is here, then you want to go mirror, how to draw? So we cannot draw already. So from here, what we need to draw, we're using second ray. Okay, just this one situation, we cannot using third ray because the object already at the C. So we're using first ray and second ray. We see how to draw. Okay, first ray is the same, parallel. After that, refracted to the F. Okay, second ray, remember, go to the F first. So we draw, go to the F, then parallel out. So from here, you can see two lines, they overlap exactly below the object, exactly below. So this one situation, we need to draw the image. The image must start from the horizontal line to draw down. So this one is the image. Okay, so from here we write the characteristic. Below the horizontal line, there's a rear. Rear partner should be inverted. Okay, one more thing, we compare the size. The size must be exactly same. Okay, when U equal to F, you get the image, sure the size is exactly same like the object. So from here, this one is a special situation. Just like that, just now, U equal F, you can get infinity. This one is U equal to F, you can get same size. So we see the characteristic. Rear, inverted, same size. Okay, then we go to the last one. Last one should be the object. Move again behind the C. Okay, now the object already moved behind the C. That means U more than 2F. Okay, now we can using third ray already because you never touching about the C. So first ray, then go to the F. Okay, then the third ray must go to the C, is it? From the object, go to the C. Okay, then we go straight to the C. So this one should be longer lah when it hit to the mirror. Hit to the mirror and refracted back. So as the same line. So they cross here. Okay, when it just cross here, that means this one is a location for the image. How to draw the image? This one is a horizontal line. Then the image must be from the horizontal line to draw, must be go downwards. So this one is a image. Okay, now we make the characteristic. Below horizontal line, there's a rear image. So rear image, the partner should be inverted. So we also can be compare object and image, there's an inverted. Okay, last one about the size. The size is become smaller. Okay, you can find it, the image size becomes smaller. Okay, just now it's the same size. Okay, the U, when it just move after the F, the first one should be magnified. Okay, when they're between, there's a magnify. When they're at the C, there's the same size. When they're after the C, there's the smallest. So we can conclude when the object after the F, they move further. When the object distance, they keep increasing. So you'll find it, the image will become smaller and smaller. So that one is a conclusion from this one ray diagram. Okay, so the characteristic is a rear, inverted, and also diminished. Diminish means become smaller. So this one is a concave mirror characteristic. Okay, due to the location of the object, we also can make one diagram about the conclusion. Okay, let's see the yellow color first. When your object located at this part that means in front the F, your image sure is a virtual upright. Okay, how about the size? The size is a magnify. Okay, now I move my object after F. After F, that means now your image become rear inverted. Rear and inverted is a partner. Okay, between F and C, if your object is located between F and C, sure magnify. Okay, now I move my object exactly at the C. Okay, exactly to the C. Rear and inverted also, but there's a image same size. Okay, just now I forget to tell you, if the object exactly at the F, the image form is at the infinity. So these 2 points is a special. Okay, the special for the characteristic. Okay, last one. If I move my object after C, that means now your object this part. So you can find the characteristic real inverted, but they become diminished. Okay, diminished. So that means this one is a conclusion related with your location for the object. Then you can see the characteristic for your image. Okay, this one is an example for the concave mirror. So you can find it, the image become inverted. Okay, you can find it, the object upright. Okay, same upright, you up, the frame is up, this one also up, but they become magnified. Okay, they become magnified. Okay, after the concave mirror, we see the convex mirror, how to draw. Okay, first one we set up. Okay, then we got F, we got C. Okay, normally the convex mirror we focus is a behind the mirror. So we draw about the first ray. Okay, this one object, first ray. Then we'll go to the F first using dotted line. Then after that, they will divert. Okay, divert, go outside. So this one is a convex mirror. Okay, then how about the third ray? Third ray is go to the C, is it? So they straightforward go to the C. So from here, where they cross, this one is a cross point. Okay, this one is a crossing point. So now we see the image that's located here. Okay, now we go to compare characteristic. This one is bigger, this one becomes smaller. So become diminished. So this one is a go up. The arrow is go upwards. This one arrow also go upwards. So we say there's a upright. And the last one, real or virtual. Can you see this one is a horizontal line? The image is above the horizontal line. They're located at the part 2. So this one is a virtual image. So we write the characteristic. Upright, virtual, and smaller. Okay, you can say about this image. Okay, this one where we use it. Okay, so you can refer some of the shopping center. They got some of the corner. They put the mirror. So this one is a convex mirror. Then you can see the image become very small, but they can show wider area. Then you can find it, the mirror is a go outside, they bend outside. Okay, so this one is a convex mirror. Okay, convex mirror, they just got one type of the characteristic. They're not same like the concave because so many, when you move the U different location, you can get the different image, virtual or upright, is it? This one, no. This one just got one type. The one type must be, okay, you see the one type must be the same like just now. There's a virtual, upright, and diminished. So we go to proof for this one. Okay, first ray, then we go to the F, then we go to divert. Okay, after that we go to the third ray, we go to the 2F, go to C, is it? Then straightforward go to C. So can you see the focus here? Okay, when the focus here, we draw from the horizontal line, the arrow is up. Okay, the arrow is up, then you write the characteristic. So this part is a virtual image. Then this one is a upright, then become diminished. So that means for the convex mirror, we just got one type of the characteristic. Always virtual, upright, diminished. Okay, we don't need to do any memorize. Okay, so this one is a convex mirror. So our lesson just until here only for the convex mirror. The next one I will show about the application for the concave and also convex mirror. So thanks for your watching. Hope you understand about it.